In this lecture, we're going to see how to model static constant member variables if we don't have access to a C++17 compiler or later. We're also going to see how to work with constant member variables that happen not to be static. And here is the rule. Before C++17, you couldn't really do much in terms of initializing your member variables in the class declaration if they are static. Only integral types, and by this I mean int and enum types, were initializable from the class declaration. Any other type would have to go in the CPP file and be initialized from there, as we are about to see. So this is the rule. Let's look at an example here. Here we have a cylinder class, and inside we have a bunch of member variables. I put in many types so that you can really see this in action and have many examples to go by. But on top here, we're going to have what we could initialize in the class declaration, and I mean wherever you declare your class, within the curly braces that englobe your class. And before C++17, you could only do this for integral types and enum. You see, int constant here is an int, and a color constant here is an enum. So if we initialize these guys in the class definition itself, this would work before C++17. But any other thing would give you a compiler error. So if we go down here, for example, we have a bunch of member variables. They are static. You see that they have the static keyword in front. But we have many types, so we have a string, we have a char pointer, we have an int, we have a float. All of these things wouldn't be initializable in the header file. If you try to do this, you're going to get a compiler error. Or I should say, in the class definition, you couldn't really initialize this thing in the class declaration here. If you do that, you're going to get a compiler error. Down here, you see that we have our double constant, which is pi here. We can't also initialize this in the class declaration because it is not in line. So we will have to do that in the CPP file. So how do you exactly initialize these guys in the CPP file? Well, I have an example for you. Here is how you could do that. Our string would be initialized like this. You have to specify the type for what you want to initialize. You have to say the class in which it's living using the double colon syntax here, and then you say the variable, and then you initialize that either using curly braces or parens, any kind of initialization is going to work here. We do the same for pi and our char pointer constant. We're going to initialize this with a string literal. This is going to work. We have an array and we can initialize that using curly braces like this. We have a float. We're going to initialize that like this with a float literal. And we can initialize a string array just like we do here. And this is going to work. Okay, so this is fine and dandy. But what about constant member variables that are not static? Let's go down here and look at an example. We have weird float here. We have wild C string and we have weird int array constant. If we try to initialize these guys in the header file, we're going to get a compiler error. This is not going to work. But if we do that in the CPP file, please remember that these guys are not static. So you will have to initialize them like you initialize any other member variable. But because they are const, they can only be initialized through an initializer list. And this is what we have here. So we're going to initialize weird float with a float literal or a double literal here, but we're going to have a narrowing conversion here. We're going to initialize our weird C string member variable with a string literal, and we're going to initialize our array of int using the syntax you see here. And this is going to work. We have to go through an initializer list if our member variable happens to be a constant. If you don't go through an initializer list and try to do something like this in the body of the constructor, you're going to get a compiler error. This is not allowed. So this is another case where we can only do this using initializer lists. And if you don't use initializer lists, you basically won't have a way to initialize your constant. This is the only way we have. Another thing I want you to know before we head over to Visual Studio Code and play with this is that if you use a static member variable to initialize another variable, you will be basically setting yourself up for disaster because static initialization order is not guaranteed. So if you run your program, some variable might be initialized before another one, and if you run the program again, the order of initialization might change. So sometimes, if you are out of luck, you might try to use a variable which hasn't been set up yet to try to initialize another variable, and your program is going to crash. My recommendation is to never use static member variables to initialize as a static member variables because that's really bad. It is recommended to only use static member variables once you have hit the main function. Because remember, they are initialized before the main function runs. You should really note this. Now that we know this, we're going to head over to Visual Studio Code and play with this a little more. Okay, here we are in our working folder. The current project is static constant before C++17 here. We are going to grab our template files and we're going to put them in place pretty quick. Let's do that. And we are going to open this in Visual Studio Code by dragging and dropping here. This is going to open our folder. We can open the main CPP file and clean this up a little bit. And we are going to put in our cylinder class because that's what we're going to play with. So let's put in the files for that. We're going to create a cylinder.h file and we're going to put together a cylinder.cpp file. I am going to grab the file for the header and I put that in here. And if you don't want to type all this, you can just grab the file from the resource section on this course. You're going to have access to this and you can use this however you want. I realize I have put this in the CPP file. It should be in the header file. So let's correct this. And inside you see that we have basically a lot of member variables and we want to play with different types so that you can really see how we do this in C++ versions lower than C++17 because sometimes you're going to run into this. If you go down here, we're going to see that int and enum can be initialized in the class declaration. This is what we should say here. Okay, so you see that we have our static constant. We are initializing this right here. If we want, we can even use the curly braces. Let's do that. This is going to work. We're going to go down and initialize our color, which is an enum that we just declared here. And again, here we can also use curly braces. This is going to work. Let's grab our thing here and put that in place. This is going to work. And this is really all we could do before C++17 in terms of initializing our static member variables inside the class declaration. For other types, you will have to put the initialization in a CPP file. So here you see a bunch of types. We have a string, we have a character pointer, which is going to be a C string. We have an int, we have a float, we have an array of const, we have an array of strings. All these things will have to be initialized in the CPP file. If you go down, you're going to see that we have our pi member variable, which is static. So this is also going to be initialized in the CPP file. So I am going to just grab the code and paste that in here. And we're going to try and understand it. This is including the header file. And we're going to initialize our member variables in the CPP file. You see, we are initializing the default color. We are initializing pi, the character pointer constant. That's going to be a C string. The array, the float static variable, and our string array. You see that we can really initialize anything in the CPP file, and this is going to work. We're going to have access to these things in the main function in a minute. The other thing I want you to see before we head over to the main function is what if you have constant member variables that are not static, because we haven't really talked about them so far. If you have those kinds of member variables in your class, things are going to be a little different. You see, we have a float, we have a character pointer, we have an int. They are constants, but they are not static. So these are going to belong to the object. They're not going to be attached to the blueprint or the class itself. Now, if you have to initialize these guys, the only option you have is to go and initialize a list like we do here. And let's be consistent here and use curly braces. Let's take out the parentheses here, and we're going to use curly braces here. Okay, so this is done. We will have to go through initializer lists. If you try to use the syntax like this and try to change the constant in the body, you won't be allowed to do this because this is a constant. And at this point, we are trying to change the constant. So C++ is going to complain. We're not allowed to do this. The only way you can put a value in your constant is in the initializer list. Because the initializer list is really not going to be changing the value. It's going to be initializing that. And it is going to put the value in the moment the member variable is created. That's why this is possible. But you can't do that in the body like we are doing here. If we do this, we're going to get a compiler error. So now that we have this, we can head over in the main function and play with these things. We're going to include our cylinder class. Let's do that. And I am going to put in a piece of code to really play with these things. I don't want to type all this because you really know most of these things. The main message is that some things can be initialized in the class declaration, some things can't. They have to be initialized in the CPP file. But now that we have these things properly initialized, we can really access them in the main function and do things with them. For example, we have the cylinder, we can print the volume, we can print the default color. This is going to work. We can access our constants. We're going to get the int constant, the color constant, the character pointer constant. We can get the array and, for example, get the second element. We can get the float constant. We can get our string array constant. We can print all these things. If we go down here, you're going to see that if we try and modify any of those constants, we're going to get a compiler error. So let's wait. You're going to see a squiggly line here, and we're going to get a compiler error if we try to modify this. Let's try and go through GCC and show you the problem. We're going to get a compiler error. You see that the build finished with errors, and we're going to get an error saying assignment of read-only variable int constant. We can't change this because it is a constant. So we're going to comment this out. You have seen this error. The other error I want you to see is if you try to modify the constant member variable in the body of your constructor, because some people are going to try and do this and they want to know what is beating them. So this is not allowed because this guy is really a constant. You have no business modifying it after it has been set up. If you do this, you're going to get a compiler error. So let's do this. We're going to build with GCC so that you can really see these things. We are learning, so don't be afraid to break things a little bit. And we're going to get an error, assignment of read-only member variable, weird float. We can't do that. Even if we are in our own constructor, this is not allowed. And we can go down and try to access some other things. So we have our weird constant here. Weird float is going to be printed out because I think it is in the public scope. We can get access to that. We're going to print that in our main function, and we're going to print all these things here. So let's build the program. Now it should build because we have fixed every single problem that we had. Build finished successfully. We can clear and run Rooster. We're going to see all the data here, and if you go and you're going to see that we have what we put in here. For example, int array, let's go down and see what we had in there. Int array constant at index 3, let's go and see what we have. Int array constant at index 3, 0, 1, 2, 3, we should get a 40, and that's what we have here. So this is working like we expect. One thing I want you to see before we wrap up this lecture is that the order static member variables are initialized in is not guaranteed to be always the same. And that can get you into trouble. To make you understand this, we're going to set up a new class. Let's call that bird, for example. And we're going to put in place two files. One is going to be a header file. Let's do that. And we're going to put in place a CPP file for that. We are going to put in place our bird class. It is really simple. All we have inside is a static constant. It is a float, so we can't really initialize that in the class declaration. We will have to initialize this in the CPP file. But what we're going to do is not initialize this with the literal. We're going to initialize this with a static member variable coming from the cylinder class. So let's do that. We're going to include cylinder, and we're going to include bird before that. Let's do that. And then we're going to say the type of our variable. So let's grab the name, and we're going to say const float, because that's what it is. And we're going to say bird, and we're going to put our scope resolution operator. We can grab this from Visual Studio Code, and we're going to initialize this. We're not going to initialize this with a literal. For example, if we put in 45.3 and say this is a float, this is going to work just fine, but we're not going to do this. We're going to initialize this with another static variable coming from the cylinder class. And let's see if we can find a float. We're going to find that here, float constant. We have it. So we're going to say cylinder float constant. Let's use this. And the compiler is going to take this. But the problem is we don't really know which one is going to be initialized first. It might be the bird weight constant. It might be the float constant here. And if we happen to initialize the weight constant before the float constant is put in place, we will be trying to access something that doesn't exist yet to try and initialize our weight constant. And you might guess what is going to happen. You're going to get a crash. Let's try and go in main and see if we can get this crash to show up. But we might not be that lucky. So we're going to try our best here. So we're going to go down, and we're going to put in the code to print the bird weight constant. For this to work, we will need to include our bird header. So let's do that. And now our code should compile at least. Let's do that. We're going to build this with GCC. And you're going to see that the build is good. But if we run the program, we might not get what we expect. So let's clear and run Rooster. This is working at this point. This is working. This is working. This is working. This is working. So this is working for now, but if you are unlucky, the bird weight constant is going to be initialized first. And it is going to either grab whatever is at this float constant member variable, the location of this thing in memory. It might grab something that doesn't exist yet. It might give you junk value. And if you are trying to access critical memory locations, you're going to get a crash, and this is really bad. So the message here is that the order for static initialization is not guaranteed. Sometimes bird weight constant is going to be initialized first. Sometimes float constant is going to be initialized first. And if this is not working in your favor, you're going to get some weird problems. Let's actually prove that float constant is 6.98 here. It is. So this is working fine, but it might not work all the time. For example, if you run this program on another machine, static initialization might not work the way it is working here, and you might be in trouble. This is really all I had to share in this lecture. I hope you found it interesting. We are going to stop here in this one. In the next one, we're going to see how you can set up member variables of the same class that you are declaring. So go ahead and finish up here and meet me there.